Now, next one we're going to go into convection. Okay, convection is the next process here. Okay, now, so how does heat travels in fluid? So fluid, take note, is not liquid, but is liquid or gas. Okay, or substances that can flow just like liquid or gas. So now let's look at an example. We talk about boiling water in a pot. Heat is transferred from the fire to the pot via conduction. And then the pot will conduct the heat to the water. Okay, so you can see here from the fire to the pot to the water is conduction. But how does the whole pot of water gets heated up? It's actually by convection. So how does it work? So we're gonna see here. Let's say we have put a little bit of a coloring here. When we heat up this point over here, okay, the water at the base, the water at this region over here gets heated up first. So what happens when it's heated? Obviously, the effect of heat is expansion. When it expands, it becomes less dense, it will rise. So you can see the movement. This purple color thing here is just to show how the hot water is moving. And when the water is on top, okay, it is cooler, or as you can say, it cools down. It will become denser and it will sink again. So you can see that the particles will linger here, it will cool down, and it will start to sink. Okay, this circulation will continue as long as there's a difference in temperature. Okay, and this is what we term as convection current, okay, which is here, convection current. So heated water expands less, then it will rise, and then when the cooler water around here is denser, it will sink. This sets up a convection current. These two, okay, sets up a convection current. So this is how convection works. For gases, it's the same thing over here. So let's say, for example, I have a candle over here. Okay, when I got a candle over here, what's going to happen is that the candle will heat up the air that's above it. So the air expands, becomes less dense, and then it will rise. Upon reaching the top, the air cools down. So when the air cools down over here, okay, when the air cools down, obviously cooling down causes contraction. When it contracts, obviously become denser and it will sink. So you realize the words come together. When you contract, become denser, it will sink. So the air here, you can see that the air will move up, it will come down. And because there's a burning paper here, okay, burning paper here, it will carry the smoke down with it, okay, to replace the hot air which is escaping. Hot air escaping, so there's a space here. So then the cool air will be dragged in. It will be dragged in and it will carry the smoke in also. So as long as there's a difference in temperature, circulation continues to set up a convection current. Okay, so take note of this one over here. So therefore, convection is actually the transfer of thermal energy by means of currents in fluid. So there must be a convection current. So that's why it's important to always state convection current. So as you can see here, it's defined as the movement of hot fluid and cold fluid circulating the stream of fluid, producing a circulating stream of fluid. So that's why normally you see convection current, you normally see like a little loop. Okay, it's like a circulatory motion. So just take note of this. This is your convection. So first one, let's look at some examples. Can heat be transmitted by convection through a solid or vacuum? Okay, obviously by solid, can it happen? For vacuum, can it happen? Answer is no. Okay, no. Because why? Remember, you talk about the medium moving. Okay, you look at the definition here. By currents in a fluid, so then in this case here, my medium must be able to move. So once again, if you look at this, solid, can my medium move? No. Okay, that medium cannot move. What is vacuum? Vacuum has no particles. So in actual fact, Molecules must be able to move, to flow or move to carry the heat via convection. Okay, or to say to transfer heat via convection. Okay, but then what happens is in solid, they are held in fixed position, while vacuum don't have any molecules. So that's why solid is a no-no, vacuum is a no-no too. Next one. So what's the similarity between conduction and convection? Okay, both conduction and convection requires a medium. Okay, requires a medium. But what's the difference? So similarity is that they both requires a medium. Okay, but what's the difference? The difference lies in here. Okay, why convection cannot occur in solid, we have covered just now, is because the particles cannot move. So convection current cannot be set up. That's why there's no solid for convection, but there is solid for conduction. For liquid and gas, it occurs for both conduction and convection also. Okay, so this marks the first part of our convection.